In that last example, we looked at how using a dictionary could let us make computation much more efficient. We store away computed values that we want to reuse, so we simply look them up. Nice idea. To demonstrate it, I showed you some examples of running the code, and we simply used the delay in time before we printed out a result to try and get a sense of how different the efficiencies were of that. I'd like a little more formal way of doing that, and I'm going to show you an example using what we call a global variable. Now, I'm going to preface this by saying this is a dangerous thing to do. Globals are something that most computer scientists don't like to use because they can really lead to side effects in a very bad way. But in some cases, they're valuable, and this is one. They're dangerous to use because global variables break the scoping of variables that we get by a function call. What do I mean by that? Remember when we were looking at a recursive function and we'd call fact on something and it would call fact on a smaller argument, and that would create a separate scope, and the value of the parameter in that scope was the one we would use, and it would be different from the value of the parameter in a different scope. With global variables, we're going to have the ability to move that value, that access to that variable, out of scopes, and that's why it's dangerous to do. It also allows for side effects because we can change variable values in ways that affect other computation. But it's going to be really handy if we just want to keep track of information inside of a function. And I want to go back to my example of fib and fib efficient to show you how that would work. I'm going to take those two definitions and I'm just going to change them slightly. In particular, I'm going to add in a variable that is going to just keep track of how often do I actually call this function. And so I'm first going to say that variable is global. And this is simply a statement. Notice global is a special term. It says this variable name is something that I can access outside the scope of the function. I'll remind you, before this, anything inside the body of the function was only accessible within the call of the function itself. But this is something we're going to be able to see up, for example, at top level at the global environment. And then what I'm going to do with both of these functions is simply increment them each time I call them. It's going to keep track of how often did I actually call this function. The rest of it is just like before. It is exactly what I did when I did these two computations. So with that small change, I can now track the efficiency of this particular pair of functions. I'm going to need to initialize that global variable outside. I'm going to set it to 0. And then what I'm going to do, for example, is I'm going to call fib on an argument like 12, and then print out a string and the number of times I called that function. Because inside that function, and I'm going to go back to that previous slide for a second, it's going to update that variable each time I call it. I'll then reinitialize it to 0. I'll set up my dictionary, and I'll do the same thing with fib efficient. And it's going to give me a chance to measure, in fact, how different are these two functions in terms of how many times are they called. So I have on my computer then those two functions. I'm going to do exactly that. I'm going to start with something a little smaller, which is 12. And I've just got a variable here, fibarg, so I can just change that rather than changing it in both places. And let's see what happened if we call this. Okay, it ran it, and it said basically I got 233 as the answer. But with the inefficient Fibonacci, there were 287 calls to that function. With the efficient one, because I'm keeping track of what I've done, only 21. All right, sounds pretty good. Let's go back to the one that we used to see a bigger difference. Let's go to, say, 30, and let's call that. I get the same answer both times. That's good. But notice the difference. Wow. Using the dictionary, I only called that function 57 times. Without the dictionary, 1.7 million. Let's just do one more. We won't make it too big or we'll be here forever, but let's, I don't know, make it 34, and let's call it. And it's going to take a little while to find that answer, but it will find it, I hope, in a second. There we go. The answer is the same. Look at the difference. With the dictionary, with keeping track of those answers, 65 calls. And boy, I got to eyeball that. 11 billion in the case of the inefficient Fibonacci. So dictionaries can be really handy here, and here's a great example of that. As we go forward, we're going to use dictionaries in a lot of different ways to really efficiently capture and use information, especially the idea of being able to index on arbitrary keys, something we're going to want to be able to use as we generalize the kinds of procedures we're going to compute.